Alrighty, here's another example of graphing a rational function. The function f of x equals x over x squared plus 2. Start by finding the roots, which are the zeros of the numerator. It's pretty obvious in this case that the only one is 0, and we'll mark that on the graph. Notice that it's also the y-intercept, or f of 0. Now for the vertical asymptotes. These are the zeros of the denominator, and when we solve for those, we see that the only zeros are non-real, so that means there are no vertical asymptotes in the graph of this function at all. The horizontal asymptotes of any function are always a bit trickier. When x is very large, we can throw away that 2 in the denominator. It really won't make any difference. Then canceling the x's, we get to 1 over x, which approaches 0 for large x. So the horizontal asymptote for this function is 0. And as a general rule, if the degree of the denominator, which is 2 here, is larger than the degree of the numerator, 1 in this example, then the horizontal asymptote is along y equals 0, always. And we'll just pencil in that asymptote right here. All right, now let's consider the symmetry of this function. Notice that the denominator is always positive. So the function just really takes on the sign of the numerator, which is negative for negative x and positive for positive x. In other words, f of negative x is equal to the negative of f of x, which makes this what we call an odd function. And that'll help us to graph it. Specifically, it rules out the lower right and upper left quadrants. So that's about all the information we need to sketch this graph. It's got to go through that 0. It can't live in the upper left or lower right quadrants. And it has to behave asymptotically as x gets large on both ends. So it really just has to look like this. And finally, here's that graph calculated with Mathematica. We were pretty close.